In this week's class, I'm just going to go through the solutions to the exam that you did last week. So make sure that you've completed the exam before you do this, and as we go through it, I want you to make corrections yourself. In the first part of question 1 here, we're given an Argand diagram where the horizontal line represents the real axis and the vertical line represents the imaginary axis. And two complex numbers have been plotted. The first one is Z1, and it clearly has a real value of 2 and an imaginary value of 3. So if I was to write this as a complex number, it would be 2 plus 3i. So the real element is 2, the imaginary element is 3. The second complex number they've marked is down here, and it's Z2. In this case, the real element is minus 4 and the imaginary one is minus 1i. So Z2 in this case would be minus 4 minus 1i. So that's all you need for the answer for the first part of this question. In part B, we're asked to plot the conjugate of Z1. So in other words, we're asked for Z1 with a bar above it. Remember that to get the conjugate of a complex number, you simply change the sign in front of the I. So if Z1 is 2 plus 3i, its conjugate will be 2 minus 3i. And I've been asked to plot that on my Argand diagram. So in this case, the real element is 2 and the imaginary element is minus 3i. So in that case, it would be down here. So your answer, what you should have done is filled in the conjugate of Z1, which is just 2 minus 3i. And you get the marks for part B for that. In part C, we're asked to prove that the modulus of Z1 is the square root of 13. In order to do that, you need to remember that we have a formula for modulus. These lines mean modulus, so the lines around Z1 are asking me to get the modulus of Z1. And to calculate that, it's the square root of a squared plus b squared, where a is the real number and b is the coefficient in front of the I. So to get the modulus of Z1, in this case it's going to be the square root of 2 squared plus 3 squared. And if you plug that into your calculator, that works out as the square root of 13. And that's what they were asking you to prove. They asked you to prove it was the root of 13, so happy days, that's all you need to do. You get your marks for that. In part D, I'm asked to simplify Z2 over the conjugate of Z1. We've already worked out that Z2 is minus 4 minus 1i, and that the conjugate of Z1 is 2 minus 3i. Remember from the class we did on complex numbers that in complex numbers, if you have an I on the bottom of a fraction, you need to eliminate it. I do not want to have an I on the bottom of this fraction. In order to eliminate the I on the bottom of this fraction, I need to multiply 2 minus 3i by its conjugate. The conjugate of 2 minus 3i is 2 plus 3i. If I multiply 2 minus 3i by 2 plus 3i, the middle terms will cancel and I'll be left with no more i's. But I can't just randomly multiply the bottom of the fraction by 2 plus 3i. If I do that on the bottom, I also have to multiply the top of the fraction by 2 plus 3i. Because 2 plus 3i over 2 plus 3i, same thing on the top and the bottom, it just has a value of 1. And it means I'm not changing the value of the expression. So all I need to do now is multiply it out. On the top, I need to multiply minus 4 minus 1i by 2 plus 3i, and I'm going to multiply that out as double brackets. Once I've done that, I then need to multiply 2 minus 3i by 2 plus 3i, and I'll multiply that out as double brackets as well. So what I've done here is I've just multiplied out the top, minus 4 minus 1i by 2 plus 3i. If you're multiplying out double brackets, it's the first thing in the first bracket by the second bracket, second thing in the first bracket by the second bracket. When I multiplied it out, I ended up with minus 8, minus 12i, minus 1i, minus 3i squared. Remember that an I squared is just a minus 1. And now minus 3 by minus 1 gives you plus 3, so minus 8 plus 3 gives you minus 5. When you multiply out your brackets on top, you just get minus 5 minus 14i. So when I multiply 2 minus 3i by 2 plus 3i, in other words the bottom of each fraction, when I multiply it out I end up with 13. Notice that when you multiply it out, you end up with plus 6i minus 6i in the middle. The middle terms cancel each other out. And that was the whole point of this. The whole point of what we're doing here is to try and eliminate the i's in the bottom of the fraction. Which this is now the bottom of the fraction is just a 13, so I've achieved it. Now let's just put both of those bits together. When I multiplied out the top, I got minus 5 minus 14i. And when I multiplied out the bottom, I got 13. Now usually the way that the marking scheme will leave it is they split up the real bit and the imaginary bit. So my advice to you is to always split it up like this. Rather than writing it as just one fraction, I took the real bit, which is minus 5 over 13, and then the imaginary bit, which is minus 14i over 13. I just have them as two separate terms. And that's your final answer for part D. Okay, question 2 part A here was quite straightforward. All I needed to do here was to multiply out at first. So what I did on the first line was I multiplied out my brackets and I got 3x plus 15 plus 12 plus 2x. I then grouped my like terms. 3x and 2x gives me 5x, 15 and 12 gives me 27. I then decided to move all my x's to one side and all my numbers to the other side. 5x minus 1x is 4x, and 19 minus 27 is minus 8. I then divided both sides by 4, and I got x equals minus 2 as my final answer. In part B, we were asked to solve a simultaneous equation, except it's a more difficult one than usual because there's an x squared and a y squared. So what I need to do is take the simple equation and isolate one of the letters. The easiest letter to isolate is y, because there's no number, it's a 1 in front of it. If I took this equation and I wanted to isolate the y, I would simply subtract 4x from both sides. And I could say that y is equal to 5 minus 4x. And now that's useful because now I can rewrite the other equation. Except I know that instead of a y, I can sub in 5 minus 4x. So let's just rewrite this equation except use this as substitution. I'm going to leave my x squared exactly as it is. Instead of y, I'm going to sub in 5 minus 4x. So y squared is going to become 5 minus 4x to be squared. And I know that that is equal to 13. So basically I've just rewritten this equation, except I've substituted in an x instead of a y. And now you should notice that I've got one equation and one unknown, which means it's possible for me to just multiply this out to factorize and then solve it. So the only tricky bit first is to multiply 5 minus 4x by 5 minus 4x. So I've multiplied out my double brackets here, and when I did, I ended up with 25 minus 20x minus 20x plus 16x squared. So that's just basic multiplying out your brackets. Then what I decided to do was to group my like terms. I have a 1x squared and a 16x squared, which adds up to 17x squared. I have minus 20x, which is minus 40x. I then added 25 at the end, and I decided to bring my 13 across and it becomes negative. 25 minus 13 is 12. Now, at this stage, I was left with a messy enough quadratic equation. The factors are 17x minus 6 times x minus 2. If you're not comfortable factorising that out, it's okay to use the minus b formula. You could have used the minus b formula simply to get straight to your answers there, which is fine. But if you factorised and solved it, your values for x are 6 over 17 and x equals 2. Now that you have two values for x, we need to sub back in up here and find the corresponding value for y. I'm going to sub each of these x values into this, and then I'll get the corresponding y values. So I'm honing in on what I wrote at the very start, that y is equal to 5 minus 4x. If x is 6 over 17, I simply subbed in, I got 5 minus 4 times 6 over 17, which if I plug all of that into my calculator, y works out as 61 over 17. So my first set of answers is x could be 6 over 17 and y could be 61 over 17. The other x value that I got was x could be equal to 2. If that was the case and I subbed in here, then y would be equal to 5 minus 4 times 2. And if I plug that into my calculator, I get minus 3. So the second set of possible answers is x is 2 and y is minus 3. So each of these are acceptable answers, and obviously you needed both of them. Okay, let's move on now to question 3 part A. In this question, you were given a quadratic equation and you were asked to solve the quadratic correct to 2 decimal places. If you're given a quadratic and you're asked to leave it to 2 decimal places or in surd form or in any weird form whatsoever, you should usually jump straight to your minus b formula. It's a hint in the question telling you need to use the minus b formula in order to solve this one. Remember, the minus b formula is available in your maths tables, and it's given, we can solve a quadratic using minus b plus or minus the square root of b squared minus 4ac over 2a, where a is the coefficient of x squared, b is the coefficient of x, and c is the number on its own. I would always advise students to write out your formula and write out what your a, b and c are. And you have to pay close attention always to the signs. Often students forget to take a minus or something along those lines. So I simply subbed everything into my minus b formula. I subbed in the 5, the 3 and the minus 1. I then simplified everything in the square root. All of the numbers in the square root. If I plug those numbers into my calculator, I get 37. And at that stage, I can just plug this into my calculator, in one case taking the plus and in the other case taking the minus. And if you do that, your two answers work out as x equals 0.18 or x equals minus 1.85. And you have to be accurate there to 2 decimal places because that's what it asked for in the question. Okay, so let's have a look at question 3 part B. In question 3 part B, we had 6 minus 4x is less than or equal to 26. If you've an inequality, it's just the same as an equation. You need to bring all your numbers to one side, all your x's to the other side. I would always advise students to move your x's to the side where it's going to be positive. So I had a minus 4x on the left, I decided to move it to the other side. Or in other words, add 4x to both sides. In which case I get a plus 4x on the right hand side. I then had a plus 26 on the right and I moved it across to the left and it became a minus 26. Now I just need to add 6 minus 26 gives me minus 20. So if minus 20 is less than or equal to 4x, divide both sides by 4 and I end up with x is greater than or equal to minus 5. And notice that the question told you that x is an element of z. And z refers to the integers. So it's telling you that x is an integer, or in other words, integers are whole numbers, all whole numbers, positive or negative. So x is greater than or equal to all the whole numbers from minus 5 going up. So to fill in your number line, you had to mark in minus 5 and then all the numbers bigger than minus 5. And that's what will give you the marks for question 3 part B. Okay, in question 4, we're told that John estimates the height of a door to be 1.3 meters. But we're told that the actual height of the door is 1.2 meters. And we're asked to work out what is John's percentage error to two significant figures. So the first thing I need to work out is how much error there actually is in John's estimate in the first place. He estimated that it was 1.3 meters when it was actually 1.2 meters. So if I find the difference between the estimate and the actual value, it's 0.1 meters. So that's the amount of error that was here. In order to get the percentage error, it's the amount of error divided by the actual height of the door. And then I multiply by 100 over 1 to turn it into a percentage. The error we've worked out was 0.1 meters, and the actual height of the door is 1.2 meters. And to get that as a percentage, you multiply by 100 over 1. And if you plug that into your calculator, it works out as 8.3%. The question asked you to leave it to two significant figures. 8 is a significant figure and 3 is a significant figure. When we're talking about significant figures, the decimal place is irrelevant. It's nothing to do with it. It's only literally how many numbers you have. You have an 8 and you have a 3. Remember, the only figures that aren't significant are zeros. So your final answer there for part A is 8.3%. In B part 1, we're just dealing with scientific notation. We're asked to multiply these two numbers by each other, and if you do that, you get 9525 and then 6 zeros. But you're asked to leave it in the form of a by 10 to the power of n, where a is greater than or equal to 1 but less than 10. Now this is scientific notation. Scientific notation, it's shorthand for really, really big numbers and really, really small numbers. Obviously here we've got a very big number, so I need to rewrite it in this format. I need to rewrite it in the form so that it's a number, and a number between 1 and 10 multiplied by 10 to the power of n. At the moment, my decimal place is clearly at the end. The decimal is at the end of the number. Where does the decimal need to be so that this number is between 1 and 10? Clearly, it wouldn't make sense for me to move the decimal to there because that would be 95.25. That's not between 1 and 10. What I want to do is I want to move the decimal place to here. If I move the decimal place after the 9, then that number is 9.5. That 9.525, and that will be between 1 and 10. So the decimal place is currently here, and I want to move it down to here. So I just need to figure out how many places am I trying to move it. So that'll be 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So that means I'm going to rewrite the decimal. I'm going to rewrite it as 9.525 by 10 to the power. And to work out what your power is, it's the number of places you've moved your decimal place. I've moved my decimal place 9 places, so it's by 10 to the power 9. If you plugged 9.525 by 10 to the power 9 into your calculator, it'll give you this as well. It's the same thing. Okay, in B part 2, you're given the mass of an electron is 9.11 by 10 to the power minus 31. And the mass of a proton is 1.67 by 10 to the power minus 27. We need to work out how many times bigger is a proton than an electron. In order to do that, you simply divide the mass of an electron into the mass of a proton. And this number divides into this number 1,833 times. So that's your final answer, and that's all you need to do for B part 2. In question 5 part A, you're given two mapping diagrams, and you're asked to identify if they're functions or not. The definition of a function is when each input gives you exactly one output. So if you look at the first one here, there's three inputs, G, H and I, and each one has exactly one output. Each one has exactly one arrow going away from it. So that means the first one here, it is a function, and if you were using that as your explanation, you could say that each input has exactly one output, so that one is a function. On the other hand, if you look at the second mapping diagram, if you look at the third one here, if you look at I, the input I has two arrows coming from it. If there's an input with two outputs, that means it is not a function. So that one is not a function, and your reason is the input I has two outputs. And that cannot occur if something is a function. First one's a function because each input has one output. Second one is not a function because there's an input with two outputs. In part B, we're given the function f of x equals 6x minus 3. And we're asked to get f of 4. If you're given a function like this, if they put something in the bracket, that simply means you sub that in for your x. Here this is the thing in the bracket is x, so it's 6 times x. Here the thing in the bracket is a 4, so it's going to be 6 times 4. Basically, you're just rewriting your function, except everywhere there was an x, you're subbing in a 4. So it becomes 6 times 4 minus 3. 6 times 4 is 24, minus 3 gives you 21. So your final answer for B part 1 is that f of 4 is equal to 21. In part 2, we're asked to find the value of k if f of k is equal to minus 33. I want you to think about what we did in B part 1. B part 1, we were asked for f of 4. So that meant everywhere there was an x, we subbed in a 4. This time, obviously what's relevant is f of k. So that means this time everywhere there's an x, I'm going to sub in a k. If the function here is f of x equals 6x minus 3. So to find f of k, I simply am going to rewrite my function, except instead of an x, sub in a k. And in that case, I would get 6 times k minus 3. So f of k is 6 times k minus 3. This question has told me that f of k is equal to minus 33. So I can say that 6 times k minus 3 is equal to minus 33. And at this stage, I've got one equation and one unknown, which means I'll be able to find the value of k. If I wanted to get k on its own, I would add 3 to both sides. And I would get 6k is equal to minus 33 plus 3. Minus 33 and 3 gives you minus 30. Now, I've isolated the term with the k, but now obviously I want to get rid of the 6. So I'm going to divide both sides by 6. If you divide the left-hand side by 6, you get k. And if you divide minus 30 by 6, you get minus 5. So your final answer for B part 2 is that k is equal to minus 5. Okay, so for B part 3, we're told that John states that this function is increasing. We need to say, do we agree with John or not, and give an explanation. If we have f of x equals 6x minus 3, I want you to just think of that as y equals 6x minus 3. This is actually a coordinate geometry question. I want you to think about coordinate geometry of the line. If a line is increasing, then that means it has a positive slope. So if we can figure out whether this line has a positive slope or not, we'll be able to tell whether John is correct or not. This line is in the form where y is on its own. Or in other words, the line is in the form y equals mx plus c. You should remember from your coordinate geometry that if you have the equation of a line where the y is on its own, then whatever's in front of the x is your slope. In this case, the thing in front of the x is a plus 6. So this line is in the form y equals mx plus c. I could say that the slope of this line is equal to plus 6. So obviously that's a positive, which means that it is increasing. It has a positive slope, and if we were to draw it, it would be going in this direction. So because it has a positive slope, we're going to agree with John. So to conclude here and get the marks, I would say that John is correct because the slope of the line is plus 6. Okay, in question 6 part A, we're given the function f of x equals 6 plus x minus x squared. And we're asked to find the derivative f dash x of that. The derivative of a constant is just 0, so 6 doesn't have a derivative. And to get the derivative of x to the power of 1, you bring the 1 in front, you bring the power in front, and you decrease the power by 1. So this is x to the power of 1. If I was to differentiate it, the 1 would come in front, and I would decrease the power of x by 1, and it would become x to the power of 0. Remember from your rules of powers that any number to the power of 0 is just 1. So in fact, you don't even need to put in the x. The derivative of x is just 1. The derivative of minus x squared, you have a minus, and then you bring your power in front, so it becomes 2x, and you decrease the power of x by 1, so it's 2x to the power of 1. So your derivative there, your final answer for the first part of this question is just 1 minus 2x. Okay, so we're then asked to let f dash x equal to 0 and find the coordinates of the turning point of the curve. So we worked out in the first part of the question that the first derivative is 1 minus 2x. But in part B, they're asking me to let that equal to 0. So I can let 1 minus 2x equal to 0. Now I just need to solve this and try and find x. What I would do first is subtract 1 from both sides. And I would get minus 2x equals minus 1. Since there's a minus in front of both sides, I would simply change my signs. I'd multiply everything by minus 1 and I'd get 2x equals 1. Now in order to get x on its own, I would divide both sides by 2 and I would end up with x is equal to a half. So I know that a turning point exists when x is equal to a half. Now once I have the x value, the question here asks me for the coordinates. So I need to find the corresponding y value. So I need to sub into the original function. If this is f of x, I need to work out what f of a half would be. I need to rewrite this function, except everywhere there's an x, I need to sub in a half. So I've subbed in here, I'm looking for f of a half, so it becomes 6 plus a half minus a half squared. And when you plug all that into your calculator, it works out as 6.25. So the turning point has an x value of a half and a y value of 6.25. So the answer to this question, that's the coordinates of your maximum point. In the last part of question 6, we need to match the function and its derivative to the corresponding curves. So I've done them out here. So f of x has to be c. The reason f of x has to be c is because f of x has a minus x squared. You should remember that a minus x squared has to be an n shape. A plus x squared is always a u shape, but if you have a negative in front of an x squared, it's going to be this shape. The only one of those graphs that has an n shape is c. And then I can also conclude that the derivative f dash x is d. The reason that f dash x is d is because it has a negative slope. This is exactly like what we did in question 5. I want you to imagine, instead of the f of x, we could use y. This is y equals 1 minus 2x. We could write that as y equals minus 2x plus 1. I'm just putting the 1 the other side of it. I just want you to recognize that once again, this would be in the form y equals mx plus c. Once again, the number in front of the x is the slope. And the number in front of this x is a minus 2. So this time the slope is negative, so that means it has to be a line that's going down. Clearly the only line that has a negative slope there was d. Okay, in question 7, we're given a rectangular box. The dimensions of the box have been labelled as x, 10 minus 2x, and 12 plus 2x. In order to get the volume of a rectangular box, it's just the length by the width by the height. Simply means I have to multiply all three dimensions by each other. So what I did first was I multiplied x by 10 minus 2x. X by 10 is 10x, x by minus 2x is minus 2x squared. I now have one bracket multiplied by another. So it's the first thing in the first bracket by the second bracket, second thing in the first bracket by the second bracket. When you multiply it out and group all your like terms, you end up with what they asked you to prove, that the volume is 120x minus 4x squared minus 4x cubed. So in part A we worked out the volume of the box is this. In part B we're asked to work out what is the value of x that will maximise the volume of the box. This is exactly the same as question 6 part B. In question 6 part B we found the maximum point on a curve. And in order to do that, we got the first derivative and we let the first derivative equal to 0 and then we solved for x. That's exactly what we're going to do here. We're going to get the first derivative, let it equal to 0 and then solve for x. That will tell me the x value of the maximum point, the maximum volume of the box. So the first thing I need to do is get the derivative here. If this is v, I need to find dv dx. If I have 120x to the power of 1, you bring the 1 in front, 1 times 120 is 120, and it becomes x to the power of 0. The derivative of minus 4x squared, you bring the 2 in front, 2 by minus 4 is minus 8, and the power of x decreases by 1 down to 1. Minus 4x cubed, you bring the 3 in front, 3 by minus 4 is minus 12, and the power of x decreases by 1 down to 2. So that's your derivative. Now in order to find the maximum or the minimum, we have to let the derivative equal to 0. So in this case it would be 120 minus 8x minus 12x squared equals 0. Now we clearly have a quadratic equation here. We have an x squared, we have an x, and we have a number. So our life will be made a lot easier if we just rearrange it another way. Write it as minus 12x squared minus 8x plus 120. Now we might be inclined now to change our signs. Since we have a minus in front of the x squared and a minus in front of the x, probably be easier if you multiply everything by minus 1 and write it as plus 12x squared plus 8x minus 120 equals 0. In this case, we could divide everything by 4 to just further make it a little bit more simple. So if I divide everything by 4, I'm going to get 3x squared plus 2x minus 30 equals 0. Now, in this case, we're not going to be able to factorize this one. So what we need to do now is use the minus b formula to solve and find x. Find the x value for the maximum possible volume. So again, I know I need to use the minus b formula because the question says to leave it to 2 decimal places. So I've simplified my quadratic to 3x squared plus 2x minus 30. In this case, a is 3, b is 2, and c is minus 30. If you sub that into your minus b formula, your answers work out as 2.85 centimetres and minus 3.51 centimetres. The reason we're getting two answers is because we're finding the maximum possible volume and the minimum possible volume. Now, obviously, you cannot have a dimension of minus 3.51 centimetres, so that one doesn't make sense. So we eliminate that one. Obviously, the x value for the maximum possible volume is if x is 2.85 centimetres. Now, the question asked me to work out the dimensions. So let's go back to the dimensions, sub in this x value, and we'll be able to work out the actual length, width, and height for the maximum possible volume of this box. So the dimensions that would create the maximum possible volume of the box are, I can find them if I simply sub in x equals 2.85 centimetres. Now I'm calling this length, width, and height, but it really doesn't matter. You could call it whatever you want. You could use breadth. They didn't refer to any dimensions, so all you need is 3 separate answers. The dimensions given were 12 plus 2x, 10 minus 2x, and x. I know that x must be 2.85 in this scenario. So 12 plus 2x would be 12 plus 2 times 2.85, which works out as 17.7 centimetres. When I sub x into the width, I get 4.3 centimetres. So these 3 dimensions would create the maximum possible volume for this box. So now we're asked to find the actual maximum possible volume of this box. I know the dimensions of the length, width, and height of the maximum possible volume, so I just multiply them all by each other. If I multiply my 3 answers from part B together, it works out as 216.9135 centimetres cubed. Okay, in part D, we're asked to draw a graph of the function for the volume. So we're no longer talking about the specific x value that we were talking about in B and C. The specific x value in B and C is for the maximum possible volume. We're now still talking about different possible x values. So I want to sub in x values from 0 the whole way up to 5. Now you can do it as a table or you can just do it all in one go on your calculator, whichever way you're comfortable with doing it. I've written it out as you could in a table here. If you sub in x equals 0 into your volume works out as 0. If you sub in x equals 1, you get 112, 2 is 192, 3 is 216, 4 is 160, and 5 is 0. I'm now left with 5 or 6 sets of coordinates. I'm just going to plot these coordinates on my graph and see what it looks like. Now, when drawing this graph, it's useful to bear in mind that we've worked out the maximum is reached at 2.85. So just marginally before your coordinate for x equals 3. I subbed in here the point 0, 0, the point 1, 112, the point 2, 192, 3, 216, 4, 160, and then 5, 0. Bearing in mind that I know the maximum is actually slightly before x equals 3. We worked out in part B, the maximum is when x is 2.85, so it's just marginally before it. But ultimately your graph needs to look like that. Hopefully yours is a lot more accurate than mine because you've got lines on your page. Obviously it's harder for me to be accurate on the glass. Okay, so obviously the company want to maximize the possible volume of the box. To maximize the volume of the box, you use the dimensions 17.7, 4.3 and 2.85. But in part E, we're being told that they need to round off these dimensions to the nearest centimetre. So obviously that implies that instead of using 17.7 centimetres, they're going to use 18 centimetres as their length. Instead of using 4.3 centimetres wide, it's going to be 4 centimetres. Instead of 2.85, they're going to use 3 centimetres. It's obviously just more convenient for them to round off these dimensions to the nearest centimetre. And now I'm being asked to find, if they did round them off, what is the volume of the box? Remember, to get the volume of a rectangular box, it's just length by width by height. It doesn't actually matter, you could call it length by breadth by width, doesn't matter, just the three dimensions multiplied by each other. So in that case, if I've rounded off, it would be 18 by 4 by 3. And if you plug that into your calculator, the volume of this box works out as 216 centimetres cubed. So if you rounded each of your dimensions off, it would be 216 centimetres cubed. So the final part of this question, we need to work out what the percentage change is. In other words, we worked out that the maximum volume of the box is 216.9135. However, the company have decided to round off their dimensions, so their boxes are going to be 216. They're going to be slightly different from the optimum volume or the maximum volume. And I need to work out the percentage change in the volume of the box if they decided to round everything off. So the first thing, to get the percentage change, then obviously the first thing I need to do is work out what the actual change is. The maximum volume was 216.9135. And that is now changed to 216. So if I subtract the new one from the old one, the actual change in terms of centimetres cubed is 0.9135. To get the percentage change, it's the change divided by the original maximum volume by 100 over 1. In this case, the change was 0.9135 and the original was 216.9135. If I multiply that by 100 over 1, I get it as a percentage, and it works out as 0.42%. Okay, for question 8, part A, we're told that Sean's gross income for a year is €53,000. We're told that his standard rate cut-off point is 32,000 and that the lower rate is 20% and the high rate is 40%. That is all of the information that we need to answer part A. All of the rest of the information is needed for part B. But all we need for part A to get the gross tax is his cut-off point and the rates of tax that he pays. The standard rate cut-off point is 32,000. That means that everyone in the country who earns 32,000 has to pay the lower rate of tax. So Sean has to pay 20% on the first €32,000 that he earns. 20% of 32,000 is €6,400. However, Sean is earning more than that. Sean earns a lot more than 32,000 because his total gross is €53,000. So if I work out his gross minus the 32,000, that gives me 21,000. So Sean is earning €21,000 above the standard rate cut-off point. Anything you earn above the standard rate cut-off point, you pay at the higher rate of tax. So Sean has to pay 40% on the remaining €21,000. 40% of 21,000 is 8,400. If I now add up both of these values, it gives me €14,800, and that's his gross tax and final answer for part A. In part B, we're asked to work out Sean's net annual income. Net income refers to the amount of money he actually gets to spend or gets to keep. His company pays $53,000, but he needs to pay tax, he needs to pay PRSI, and he needs to pay USC. If I subtract his tax, PRSI, and USC from his gross income, that will tell me his net annual income. So before we look too much into that, I want to just finish off the tax. In Part A, you were only asked for the gross tax, but notice that they've told you he's entitled to a tax credit. So, because people don't actually have to pay all of their tax. So he has a tax credit of 2450. If I subtract that from his gross tax, that tells me his net tax, the amount of tax that he actually has to pay. So the amount of tax that he actually has to pay is €12,350. Now I want to just work out how much PRSI does he have to pay. I've been given his USC, so I'll just subtract the three figures from this, and that will tell me his net annual income. So we know that Sean's net tax is €12,350. That's the amount of tax he actually has to pay. We've been told his USC is 2208.06, and we've told that his PRSI is 4% of his gross income. So to get that, it's just simply 4% of 53,000, which is 2,120. If I add the PRSI, the net tax, and the USC, I get this figure, which is the total deductions. The total amount of money that is taken out of Sean's gross income before he gets his take-home pay. His gross income was 53,000. If I subtract his total deductions, I'm left with his net income. The amount of money he actually gets to take home is €36,321.94. And that gets you the marks for this part of the question. Okay, the maths in part C is really straightforward, but it is kind of tricky to wrap your head around. Sean's gross income has increased. So he's no longer earning 53,000, he's earning something more than 53,000. To the point where he receives an extra €1,050. So after all his deductions have been paid, he's getting an extra €1,050. The only thing that will be affected, the USC is not affected, the PRSI is not affected. The only thing that is affected, we're told, is the tax. So he's no longer on 53,000. He's on a number bigger than 53,000. But I want to think about what we did in Part A. In Part A, we worked out that on the first €32,000 he earns, he's going to pay 20% tax. And then on anything above that, he's going to pay 40% tax. Anything he earns more than 32,000, he pays 40% tax. So I said 53 minus 32 means that he earns €21,000 above this figure. And he pays 40% tax on it. Now I want you to think about that. If he's paying 40% of this €21,000, 40% of it is taxed, which means that he receives 60%. If the government gets 40% of it, he gets 60% of it, and that's the key to this question. Because this figure is bigger than 53,000. It's something, it's different. It's maybe 55,000. It's a bigger number. Now I'm only making this up and this is not the answer, but let's say that this did increase to 55,000. If it did, this entire line would stay the exact same. Nothing would change about that line. He would still pay 20% on the first €32,000 he earns. The thing that would change is this figure. This figure would no longer be 21,000. It would be more than that. Because the difference between 32,000 and the amount he's earning is more than 21,000. So whatever amount of money, let's say that he got a $2,000 increase. If he got a $2,000 increase, all of it would have been charged at 40% tax, which means that he would have received 60%. He received 60% of the increase in his gross income. He only gets 60% of it, the government gets 40% of it. But I know what the increase was. I know that his salary has increased by €1,050. And I know that that corresponds to 60% of the original increase. He got an extra €1,050 after he's already paid 40% of it in tax. If the government gets 40% of it, he gets 60% of it. So if I know 60% of his increase, I can work out what 100% of his increase was. Remember the way that we dealt with percentages a few weeks ago. If I know 60% is equal to 1,050, the easiest thing to do is to first get 1%. In order to turn 60 into 1, I have to divide by 60. If I divide the right hand side by 60, I also must divide the left hand side by 60. 1050 divided by 60 is 17.5. So 1% of the increase in his gross income is 17.5. I'm not interested in 1%, I want 100%. So I'm going to multiply the right hand side by 100, and that'll give me 100%, and multiply the left hand side by 100. 17.5 by 100 is 1,750 euro. So that is the amount of money that his gross income has increased by. We were told at the start of this question his original gross income was 53,000 euro. But I'm just after working out that his gross income has increased by 1,750 euro. If I add these two together, I work out his new gross income must be 54,750 euro. And that's your answer for part C. In part D, we're told that Sean wants to take out a loan of 12,000 euro and that APR is going to be applied at 4.5% and that he's going to pay it off over the course of 4 years. If you go to page 30 in your maths tables, there's a formula for compound interest. We've been told he's paying compound interest, so the formula F equals P times 1 plus I to the power T is relevant. P is the amount of the original loan, in this case 12,000. I is the interest rate divided by 100. So you get your interest rate as a percentage and then you divide it by 100 and it's 0.045. T is the number of years that this interest is going to be applied, in this case 4. And then F is what I'm trying to find, how much money he actually has to pay. And if I just plug into my formula, I know everything except for my F. So instead of P I put in 12,000, instead of I 0.045, and instead of T I put in a 4. If you plug all of that into your calculator, the amount of money he's going to have to pay back on his 12,000 euro loan is 14,310 euro. Now part D is slightly different. We're told that he might want to pay this back in monthly installments rather than yearly installments. So I want to talk to you about this. It's straightforward enough, but we haven't come across it before. The yearly interest rate is 4.5%. And I worked out that we divided I by 100 and we wrote it as 0.045. In order to turn a yearly interest rate into a monthly interest rate, we take the 1 plus I, that part of the formula for compound interest. So if the interest rate is 4.5%, you convert it to 0.045 and then add 1. And I would say that the yearly interest rate is 1.045. That's the format I need my yearly interest rate in order to turn it into a monthly interest rate. In order to turn this into a monthly interest rate, I need to get the yearly interest rate to the power of 1/12, because there are 12 months in a year. If you get the yearly interest rate to the power of 1/12, that is equal to the monthly interest rate. So that's exactly what I'm going to do. So all I need to do in this case, the yearly interest rate is 1.045. To turn it into the monthly interest rate, I need to get the yearly interest rate to the power of 1/12. And if you plug that into your calculator, it's going to work out as 1.00367. Now if you're asked so this is the monthly interest rate represented like this. If you're asked for interest rates, you're expected to write it as a decimal. Now I want you to realize that for the yearly interest rate, I just added in a 1. It just, in this format, it makes it a lot easier. So in this case, the monthly interest rate, I don't need the 1 at all. I needed the 1 in my calculator in order to get this value. But the monthly interest rate is 0.00367. In the previous question, we were given the interest rate as a percentage and we divided by 100 in order to turn it into a decimal. In this question, we have the interest rate as a decimal. We're going to have to multiply it by 100 to turn it into a percentage. So if I multiply this by 100, the interest rate as a percentage is 0.367%. And that is the monthly interest rate that corresponds to a yearly interest rate of 4.5%. Now in the last question on this test, you were given the first 3 stages of a pattern and asked to fill in the next 2 stages. The first stage had 1 tile, the second stage had 3, the third one is 5, the fourth one will have 7, and the fifth one will have 9. So that's what you needed for part A, and for part B you had to fill in the pattern as 1, 3, 5, 7, 9. Clearly we can see here that the pattern is increasing in 2 tiles every time. In part C, Michelle claims that the pattern is linear. In order to prove that a pattern is linear, you need to prove it has a common first difference. So I'd write it out like this and clearly indicate that the difference between the first five stages is 2 in each case. So you could say, I agree with Michelle, the pattern has a common first difference of +2. Okay, in part D, you're asked to get Tn, the general formula for the pattern. The easiest way to get the general formula for the pattern is to go to page 22 in your maths tables and find the formula Tn for an arithmetic or linear pattern. The formula is a plus n minus 1 times d. In n, there's going to be an n in your answer because you're looking for the nth pattern, so you don't need to sub in for n. But the maths tables tells us that a refers to the first term. Clearly the first term in this sequence is 1. And d refers to the common difference, which we've already worked out is +2. So I can simply use a equals 1 and d equals 2, sub into the formula on page 22 and get Tn. So if I substrate in this case I'm going to get 1 plus n minus 1 times 2. Now n minus 1 times 2, I know often the fact that the d is at the end of that bracket confuses people. Rather than putting the 2 there, I can just put the 2 in front. It's the same thing, and now I can just multiply it out. The only reason I changed the 2 is because you're used to seeing the numbers in front of the bracket that you multiply in. 2 by n gives you 2n, 2 by minus 1 gives you minus 2. Now if I group my like terms, I have a 2n, and then I have 1 minus 2. 1 minus 2 just gives me minus 1. So your general formula for this pattern, Tn, is just equal to 2n minus 1. So if I've worked out Tn, the general formula for the pattern, I can get any term. I can get T50 or T60 or T a million or whatever I want. Or for example, what they've asked me in part E is for T21. That simply means instead of an n, you sub in 21. So 2n minus 1 will become 2 times 21 minus 1. 2 multiplied by 21 is 42, minus 1 gives me 41. So the 21st term, T21, will have 41 tiles in it. But part F is the opposite of part E. In part E, I wanted to work out how many tiles are in the 21st pattern. So I subbed in 21 for n, and I worked out that that's equal to 41. Whereas in part F, I want to work out which pattern has 87 tiles. That's different. So I want to know what is the value of n for which this general formula will be equal to 87. So this time I let my general formula 2n minus 1 equal to 87. I have one equation and I have one unknown, which means I'll be able to find the value for n. The first thing I do here is add 1 to both sides, and I would get 2n is equal to 87 plus 1. 87 plus 1 is simply 88. Now in order to get n on its own, I would divide both sides by 2. 2n divided by 2 is just n, and 88 divided by 2 is 44. That tells me that the 44th pattern in this sequence will have 87 tiles in it. And that's your final answer for part F. So I hope you're happy enough with all of this video. If there's anything you're struggling with there, then make sure you get onto myself or you get onto Evangeline and we'll try and explain it differently.